This is the water cycle section 2 called cooling in the water cycle. Last week it was heating in the water cycle. This week we're going to talk about cooling in the water cycle. The water molecule you've been following is now part of a water vapor in the sky. That's because it evaporated. As the water molecule rises higher and higher into the atmosphere, the air becomes increasingly cooler. The cooler air causes the water molecule to lose energy and slow down. Remember, when things get colder, the molecules move slower. What happens to water vapor when the water molecules slow down? Condensation. When the molecules in water vapor slow down, they connect with other water molecules. As more water molecules join together, the water vapor changes to liquid water in the form of tiny droplets. A change in state from a gas to a liquid is called condensation. As figure 2 shows, right here, when the atmosphere cools, water vapor condenses on tiny dust particles to form liquid water. So we have water molecules in the air right here, and they get attracted to little dust particles that are in the air, and then they create the droplets. They create the water droplets. Note also that when the temperature is very cold, the water vapor can freeze, turning into a solid, otherwise known as ice. Recall that water molecules in a gas state are relatively far apart. Remember, because they're zooming around their entire container. In a liquid form, the molecules are much closer together and their movements are more restricted. So they're connected to each other, but they flow over each other in the liquid state. Just as water molecules absorb energy during evaporation, they release energy during condensation. Condensation is an important part of the water cycle because it is what causes clouds to form. When water vapor rises in the atmosphere and cools, it condenses onto dust and other tiny particles to form water droplets that make up clouds. Condensation can also happen on the objects around you. For example, have you ever noticed water droplets on the inside of a window? This can happen on a cold day. Let's go back up to this image, the water droplets on the inside of a window. So this can happen on a cold day when warm, moist indoor air comes in contact with a cold window. Condensation also happens on car windows, mirrors, and even your eyeglasses if you step outside a cool building on a hot, humid day. Crystallization. Crystallization is another process similar to condensation. It's referred to earlier in this section as the temperature gets so cold that those water droplets freeze. Crystallization is a change in state from a gas or a liquid to a solid. While condensation forms liquid water droplets, crystallization forms ice or solid water. Crystallization occurs when the air temperature falls below freezing and water molecules stick tightly together. Clouds can be made up of both water droplets and water crystals. When water vapor or liquid water crystallize, energy is released into the surrounding air. As you may recall, crystallization forms solid structures called crystals, which are made of atoms arranged in a repeating geometric pattern. When the temperature is below the freezing point of water, the water molecules crystallize and become solid, like a snowflake. Crystallization causes water molecules to stick together in organized arrangements to form the intricate, repeating geometric patterns of snowflakes. Crystallization can form snowflakes high in the atmosphere, but it can also happen anywhere there is water vapor or water droplets and the temperature is below freezing. Have you ever noticed frost on the outside of a window in the winter? Frost is the result of the process of crystallization. Evaporation, condensation, and crystallization are only part of the water cycle story. What other important processes drive the water cycle? What happens next after water condenses or crystallizes to form clouds? We'll talk about that next week. For this week, I want you to focus on condensation and crystallization.